The chi-square test of independence. So we use this test to analyze the frequencies of two variables with multiple categories to determine whether the two variables are independent or not. The null hypothesis is then that the two variables are independent versus the alternative hypothesis is that the two variables are not independent. Okay, so if we reject the null hypothesis, that means the two variables are not independent. Okay, so the formula is similar to our chi-square test of the goodness of fit test, where you have the sum. So the test statistic is the sum of the observed frequencies, subtract the expected frequencies, what you would expect to see, all squared, divided by the expected frequencies. So the observed counts, subtract the expected counts, divided by the expected counts. Don't forget to square the numerator, add those all up. The degrees of freedom is R, which is the number of rows, subtract 1, multiply by C, which is the number of columns, subtract 1. Okay, because what we're doing is we organize the two distributions into a contingency table. So you have distribution 1 here, distribution 2 here, and what we're testing is to see if the two are independent or not. The expected counts, or the frequencies there, is calculated by taking this little formula here, E subscript ij, where I is the number of rows and j is the number of columns. So you take the total number for that cell's row, multiply it by the total number of that cell's column, divided by n, which is the total number of counts in the entire contingency table. So we'll look at an example here. I'm taking this example from the course textbook, pages 708 and 709. So we're looking at the type of beverage and age of consumer. So we have two variables, and we're going to see if they are independent of each other. So is the type of beverage ordered with lunch at a restaurant independent of the age of the consumer? So a random poll, that should say, of 309 lunch customers is taken, resulting in the following contingency table of observed values. So these are the observed values. Conduct a test of independence using alpha of 0.05. So out of 309 lunch customers from the poll, 26 of them were between the age of 21 and 34, and they preferred coffee or tea. So let's first calculate what we would have expected to see out of 309 lunch customers. So we observed 26, but what should we have expected to see? So we take the row total, multiply it by the column total, and divide by the grand total. And we get, should be 40.94. Okay, and to keep track, you can even put those in brackets, 40.94. So we observed 26 customers, but we would have expected 40.94 based on this data. And you do the same thing for each cell. So there's 9 cells, right? Because we have 3 categories for age, 3 categories for beverage, right? Coffee, tea, soft drink, or other, which is milk or etc. And you do that for each cell, and then you add them up. So, well, you add them up from this formula. So for the, let's take the first cell. So we observe 26 customers, subtract what we would have expected based on this data, and square that, divided by 40.94. And you continue to do that for each of the cells, for each category. So there will be 9 in total. And if you add those all up, you should get 59.41. Now we determine the degrees of freedom. So the degrees of freedom are equal to the number of rows, which we have 3, subtract 1, multiply by the number of columns, which is 3 as well, subtract 1, that ends up being 4 degrees of freedom. Okay, so we want to remember this number here, 59.41. We're going to compare it to the chi-square critical value. All right, so we will look at alpha, 0.05. We said there were 4 degrees of freedom. So we have this here. So this is our chi-square star, 9.4877. And our chi-square that we observed was, it was 59.41. So it's a lot larger than our critical value, right? And so therefore we reject the null hypothesis that the 2 variables are independent. Therefore we can conclude, I'll just go back. We can conclude that the preferred beverage and age are dependent of each other. Okay, so that means there is a correlation between the 2, and they are not independent. They are actually, in fact, dependent. So depending on the age, it can probably be safe to predict which beverage they predict or prefer. Okay, and that's how you conduct the chi-square test of independence.